So first of all, thank you very much for joining us tonight here on the very first meetup of the year with Kubernetes Australia. And I'm very proud and honored to announce this being our 10th meetup that has occurred. And very excited to announce that we've officially hit 1,000 and over meetup members in Australia. So round of applause for you all, and thank you. So before we begin, I'd like to hand over to Daniel from NAB, who has arranged this amazing opportunity for us to have some quick words on housekeeping and so forth. Thank you.
Thank you. So welcome everyone. You're at the Events Hub at 395 Burke Street. Just some housekeeping. I mentioned before, but there are rubbish bins out. If you go out and to the right on the wall, there are rubbish bins there. There are also toilets. If you keep on going, they're against the wall. The door handle doesn't turn, but if you just keep pushing harder, it will eventually open the door. In the case of emergency, our gathering point is Flagstaff Gardens. Hopefully we won't have to walk that far, but if anything did happen, that's where it is. And please use the front exits if anything did like that happen. If you do need any assistance throughout the night, please reach out to myself. There are a few other NAB people here, so if you can talk to them as well. And there's also our security guard at the front if you need any assistance like that. So I think that's everything for housekeeping. But yes, if you do need anything, please reach out. Thank you.
Thank you again, Daniel. So without further ado, I'd like to get the night moving. And first of all, quickly acknowledge the traditional lands on which we are gathered here tonight. And on behalf of Kubernetes Australia, we formally pay our respect and respectfully do acknowledge the traditional land of the Kulin Nation on which we are gathered and pay our respects to elders past, present, emerging. So our mission as Kubernetes or K8SUG, you might have heard, we are very passionate about the technologies around Kubernetes, and our mission is to accelerate the adoption. And we really wish to just learn from each other, share the best practices along the way. So this has been a mission since 2022, which sounds like a long time ago now. So tonight, what we have lined up here at NAB is two very exciting topics presented by amazing speakers, which you may have already chatted with. First of all, we have Jay from NAB, who's a principal engineer. He'll be talking about NAB's journey for adopting managed Kubernetes as a platform with centralized CI/CD as a service. And secondly, we will have Frank from AWS, who's a specialist solution architect, talking about harnessing the power of Karpenter to scale, optimize, and upgrade Kubernetes. So this is a topic on open source technology. And just quickly, I know this is the first event of the year, but we like to keep you updated and show that we are, in fact, the most active Kubernetes meetup group. So here's our upcoming events, which you can see not only happens in Australia and Melbourne locally, but also we have launched a Canadian group last year. So you are welcome to join us online for that or watch the recording, which I will posted. And so that one at AWS will be on the 25th of January, which is actually, yes, tomorrow, their time. And the Singapore group have their monthly meetup at Google on the 22nd of February. And then next month, Australia again will have our meetup at Microsoft. So we do get a range of event sponsors, which we're very grateful for. So now I would like to talk about another initiative we were really excited to kick off at the end of last year. So the Kubernetes workshops. So I invite our founder, Yong Kang, to come have a quick talk about this.
Thanks, Louisa. First of all, thanks everybody for joining us. Yeah, I'm very excited to be here to talk about, to introduce you guys to join us to learn. And my name is Yong Kang He. I set up the K8SUG Kubernetes user group from 2022. So far, we already grow pretty fast. Even Australia team will already have 1,000 members. So part of this, I love Kubernetes. I love to learn. I'm fully certified on Kubernetes. And I also feel like the whole market, Australia, we need a lot of more Kubernetes experts. So we are going to introduce the free learning. So one of my friends, He's going to run the workshop. He's going to talk about the Kubernetes 101, which we already did some time back. And we're going to continuously to introduce some more topics. So feel free to join us. I believe we do have a QR code here. So please feel free to take a screenshot. And we're planning to do another one February 8th. So we will talk about the Kubernetes 102, mainly focusing on the networking and the storage. If you did not get a QR code, don't worry. I will share the slide deck as well. Okay, feel free to join our Telegram group chat. So we will share the slide deck after the meetup. And with that, I'd like to thanks to our main sponsors. So CNCF is one of my main sponsor, and together with CloudCasa, also one of my main sponsor, and also Code Cloud. I don't know if anyone not know any one of these. Anyone never heard of CNCF? Yeah, everybody know, right? What about CloudCasa? Okay. So CloudCasa is one of the best Kubernetes backup tool. Feel free to give it a try. They do have the free options. And the Code Cloud, anyone heard of a Code Cloud? Yeah, it's one of the best Kubernetes learning platform. I just used their platform to did my second CKS. So that's the Kubernetes security specialist. So we are very happy to have Code Cloud also sponsor us 3 Code Cloud platform access. So today we also have CloudCasa sponsor us some, I think some pens. So the nice pen you can use the other side as a to use to write on your laptop or your phone. And also we'd like to thanks to NAB. Daniel already showed up earlier to sponsor us the venue. Without the venue, we won't be able to make the meetup happen. Also, AWS sponsors the food drinks. So very much appreciate to our sponsors, but we are continuously to looking for more sponsors. So I'd like to give everybody like a swag take home, but we need more sponsors to join us. So also thanks to our volunteers. I know a lot of our volunteers are here today. So we got Mark, we got Susan. So Harrison wasn't here today. Prasanna was here, and Tiago was here. Yan was here. So we actually not only we are running the most active Kubernetes meetup, we also have the most active volunteers to helping us. So anyone want to join us? So here you go. So you can join us as a speaker. So like Jay and Frank will talk shortly. So if you have any good topics, you learn something new about anything about the Kubernetes ecosystem, join us to share with the community. And you can join us as a volunteer as well. Also, we're looking for more sponsors. So could be sponsors anything. So like the swags, like the venue, like the food drinks, or maybe sponsors KubeCon tickets, okay? So feel free to follow us. So we are available on LinkedIn. So we are also one of the fastest growing LinkedIn profile. So far we got 3,100 followers. We only started the page in like 6 months ago. And feel free to follow our Twitter page. Sorry, the color is slightly different because my friend made it the first 2 and I made it the last one. So the color, I could not make it exactly the same look and the feel. So Telegram group, we also have 1,000 members. Yeah, we often share the slide deck. People might asking some question. I want to do something, I don't know how to do it. So these guys from the group can help you to answer the questions. Your feedback is very important. We will come back for the feedbacks. So if you want to take a screenshot, do the feedback typically after the session. Okay, yeah, feel free to take a photo for now. So with that, I'm going to hand it over to Jay first to talk about the NAB's Kubernetes journey. That's the real world experience sharing. So let's give him applause. Thanks.
All right. Hello, everyone. My name's Jay. As mentioned before, principal engineer at NAB Engineering Foundation. So I've been at NAB for almost 3 years and 9 months. Started off with what everyone loves, Jenkins and pipelines, and found all the complexities of managing the plugins, what we'd like to call plugin hell, and went on to the journeys of managing things like ECS and Kubernetes and so forth. So NAB is primarily across Azure and AWS, although we do have a small footprint on Google Cloud. So we try to sort of balance the workloads between the two. Zoom as well. Okay. Sorry, guys. Yeah. Yep. Yeah, I try to fit in all the agendas in there. Sorry, it might be a bit of a long one. So if I can fit it in time to talk about it in detail of each one of the slides, I'll try to. Otherwise, I'll try to make it a bit concise, and we can talk about it later if you want. Feel free to just come up and chat with me afterwards. So I'm just gonna skip this and get to the next slide. So at NAB, so the scale that we're working at, so we got around about 300 EKS clusters across non-prod and prod. So that's actually centrally managed by our team called NAB Engineering Foundation, and patching and everything that we deal with it as well. So then we have another flip side, which is on Azure side, which is running on around about 12 centralized AKS clusters. So that essentially means that there are two different models that we operate at. So one being on Azure side is multi-tenanted centralized cluster, where we would have different teams going into sort of soft Kubernetes tenancy model using namespaces. Then we have a complete cluster isolation that actually we manage cross account for 300 EKS clusters and growing as well. We also have roughly currently as part of our central platform, we now call NAB 2.0, around about 1,800 services. So that's across microservices and front end, and they are also all completely standardized all the way up to the libraries and the patterns in terms of Java, Spring Boot libraries, and all Python and Node.js support and all that sort of stuff. And also the front end, obviously, with the using React and Nginx and so forth. So that also means that we have many teams that we support, with varying levels of degrees of expertise, around about 140 teams currently as we speak. Also about 2,000 pipeline instances from centralized templates. So we kind of, because this is Kubernetes Meetup, I'm not going to talk too much about that area, but we do have lots of sort of structures of how we actually publish these things and centrally manage them as well with version. That also have around about 1,100 environments across all the application teams, and we help to make sure that to define what that actually means for each environment and how do we make sure they are compliant before they go to production in a safe and efficient manner. And I think I did the numbers yesterday. It's around about 800 deployments a day. So it's okay. We want to grow it better, and hit the target of at least about 2,000 deployments a day. So as with anything, any sort of IT strategy, we need to sort of start with why and motivation. So here's a quote from Andrew Bryden, our chief engineer at NAB. So teams were individually building same components for the cloud and applications in the cloud in slightly different ways. So that means initially the problem surfaced from non-standard fragmented components. So that's identified our Andrew Bryden, who's our chief engineer, when he created NEF. So he's a founder of NEF, the whole initiative of the team and why that exists. And this vision actually was actually created 4 years ago. And it still remains the same. So it's pinnacle to everything that we do with our team. So try to make this pretty quick. So we started, where were we? So before we get into sort of centralized CI/CD, the initial state was, we had lots of Jenkins pipelines maintained across hundreds of application teams. They also had about thousands of CI/CD pipelines across, hundreds of, whether you call it Jenkins master or Jenkins agent, and plugins, and you have to learn Groovy, and customize those libraries and try to solve like backup and restore commands for AWS CLIs and so forth. And teams were trying to solve those problems in kind of silos, not sort of reusing it in a proper standardized manner. So we try to sort of standardize it as well. So we keep that model, try to still maintain, and the application team manages that, but also have users some centralized libraries that we provide. So I'm not sure if you heard of things like Jenkins templating engine and those kind of things. We kind of try to use those models to sort of abstract away all the complexities and use those libraries as a sort of standard offering for reusable components. That also created, like, some teams were very sort of skilled at this management of Jenkins. Some teams weren't. So we had many teams that were asking for help. Like, you're the central team, you know everything about Jenkins, and can you help us write Groovy scripts and things like that? So that was interesting. On top of that as well, we were obviously also providing scripts to deploy to ECS clusters, which are also managed by application teams. If you see this topology, so in terms of the shared responsibility model, the yellow part at the top here is where responsibility of the service team lies, and the blue part at the bottom here is our team, so which is NavServe team, which is under NEF, that manages the infrastructure code and Jenkins pipeline code and so on. So we don't actually do the deployment, but we're actually providing them as patterns that they can pull in and do some deployment on their accounts. So that was the kind of initial state, and it was okay, but the problem is that since you're administrator of Jenkins, that people would override a few things and skip scans and any other sort of code quality checks, would automatically try to promote without any sort of unit tests and things like that, and then deploy to production. So those kind of things we just kind of noticed as a problem in terms of decentralized Jenkins. There were teams who sort of had a single pipeline, so it really wasn't worth having a maintenance of the infrastructure. That way we provide a sort of enterprise Jenkins that we manage, and people come in and use the pipelines. I try to put some of those key ones that we use at NAB in terms of tooling. These are sort of really giving an idea of how many things that developers actually need to learn to make sure they're compliant and deploy all the way up to production. So pathway to production, ensuring they're safe and compliant and all that is difficult. And trying to learn these things, even the names of them is quite hard. So it emphasizes again about the importance of the central team trying to abstract away all these complexities. Getting back to the motivation and why. So, initially the problem surfaced from non-standard fragmented components, not just at the level of the pipelines. And when you create this vision is also, expanded towards our centralized platforms. Like for CI/CD now, we actually run on a tool called Harness. Then we also have obviously EKS and AKS for running those applications. Right. So the goals, deployment of the applications on managed Kubernetes platform. So before I said all the application teams, we also call it asset team. So the asset teams would actually manage the ECS clusters themselves with all the Terraform and Ansible and infrastructure code that does the deployment. So that was a challenge for us to deploy those existing services into AKS and EKS equivalent. So we have running applications in ECS. So we would actually start with kind of like a dormant deployment onto AKS and EKS, depending on the requirements. We would go through the review of those applications. So ensure they do normal things like standard out for application logging, looking at network traffic and firewalls for existing dependencies like databases. And we wanted to make sure that we focus on the standard services first. So earlier on, I mentioned about the standard services with 1,800 services that we have all the way down to the libraries. Those standardization efforts was worth it later on because we were able to grab those configurations as a known state. Then we would use automated scripts to automatically migrate into different platform as well. So that was a good sort of trade-off from initial effort to migrate to that. So we have a compliance and security built in at every stage of the pipeline and Kubernetes runtime. So pipeline should have non-prod and prod separated. So only to allow immutable versions, security scanned and tested prior to the deployment. Ensure the container images are separate from production repositories and scanned and promoted using what we have a thing called Deputy, which is a compliance engine behind the scene that actually checks against the attestation partners. So we try to actually make sure that we want to actually make it as a releasable production artifact in images. So we store images in Artifactory. Those need to be tested and attested against a Deputy engine that we have. Operational readiness. So provide abstraction enough so the engineers would not have to run any kubectl commands. So we were aiming to make sure that it's abstracted enough so that engineers can run things, but without having to learn too much about Kubernetes. So if you think about it, it's not just the technicals, right? You have all other things in play at the scale of NAB. So things like penetration testing is one of them. Then you got the consistent naming conditions that needs to be solved, and rollback capabilities and patching strategies. So it's just many things that comes into play, not in terms of process-wise and compliance-wise and security-wise, other than just technicals. Multi-cloud. So NAB has an obligation to make kind of like a 50-50 between the workloads between Azure and Amazon. And we need to make sure that we have a reusable application Kubernetes manifest. That was the goal that we had. So whether you're on AKS or EKS, there are differences between the two, but Kubernetes was mainly chosen for the fact that we could use very similar Kubernetes manifest and across AKS, EKS as well. Another part here is to avoid using cloud-specific SDKs. So there were applications while we were doing some reviews, found out that they're using things like specific Azure Key Vault or SSM parameters to store secrets. We actually use HashiCorp Vault for storing the secrets, and any one of those things that when we found out of our code scanning, we would exclude them as part of the priority. So we would try to find out low-hanging fruit first, and then gradually follow up on the lower priority ones that might require code refactoring, and gradually follow up with numbers as well. And support models. Thinking really in terms of SLIs and SLOs, adhering to the compliance, security, and engineering guidelines. You have to factor in things like disaster recovery for process for hot fixes. To start with, pick the low-hanging fruit again, and then move the other ones later. Looking at things like pod destruction budgets, make sure that they're sort of exposed and easily usable for application side to make sure that they have guaranteed uptimes while we do the patching as a platform team because we don't manage the applications. Centralized ham charts. So that's really to adhere to hyper standardization strategy that we have at the bank for all these microservice container deployments. So Kubernetes landing zone. So how do we manage these things? So there's a concept called hub and spoke model. So hub and spoke solves the problems of centrally managing multiple Kubernetes clusters deployed on Spoke accounts. We use Terraform and Kubernetes providers. So we had to look at different sort of tools and found out that it was quite useful to have not just for infrastructure deployment, but for Kubernetes manifest for the platform team only. So that means using the same language syntax, reusable variables, and also automatic dependency resolutions as well. AKS versus EKS. Execution-wise, we would look at things like, differences between the two would be AKS on Ubuntu is allowed for the worker node, with Azure CNI comes with Calico network policy. With EKS comes with things like IRSA, IAM service account, and security group for pods, Karpenter, although there's now Azure support for that ish now, and custom AMIs and so forth. Multi-tenancy for shared clusters. I mentioned a little bit before about AKS, namespace isolation for application and teams for CI/CD agents and pods. You may need to need a dedicated cluster for apps requiring separate control plane. For example, think of like PCI DSS. Alert and cluster monitoring. So alert CPU and pod limit, number of container restarts for etc. So for cluster monitoring, we use App Dynamics and run cluster agents to monitor Kubernetes cluster. So there's a separate section we register on App Dynamics and centrally manage that agnostic to the cloud. So you would see all the details around pod and pod describe image and that sort of stuff in there, and namespaces and so forth. We would also monitor things like ejection count and image pool errors, if it happens too often, pod queues and CPU utilizations. And all provisioned cluster logs should go into central team index. So we use a thing called fluidity operator, kind of switching into from bit now. And also going into, before we used to have a Kafka topic, we would actually send all of the logs to where we would forward it to the Splunk index using heavy photo afterwards. Those kind of things have changed. Now we use a thing called Krigel to actually ingest the data through. And we use it would use also the daemon set on each node to collect the logs instead of the sidecar for failure tolerance and scalable aggregation. For secrets management, we use Kubernetes annotation. So ensure you mount secrets as volumes and not environment on manifest. So we use a Vault injector to do that. So when we were actually implementing the Kubernetes platform, that was the main thing that was provided by the HashiCorp. So we decided to use that. And also to make sure that it's cloud agnostic, we wouldn't use things like AWS Auth on the Vault side. We would use Kubernetes Auth and maintain this kind of parity authentication. And we would make that visually available by actually sourcing them as files and available in the runtime so that the applications would just consume it as environment variables. Routing and TLS termination. So we use Nginx Ingress controller. So if you're not ready for the service mesh yet, ensure you implement end-to-end encryption controller. So that means like do a pass-through rather than actually terminating at the Ingress controller level. You do a pass-through and then terminate at the pod level. Though I think, Josh, we talked about something different before. And you can also utilize things like virtual server and route or canary annotation to implement traffic shifting on canary deployments as well. Gatekeeper with OPA policies implemented. So ensure auto mounting of the service account token is disabled because not every pod requires kubectl access into the API server. Disallow any unnecessary kernel capabilities using on the security context. So disable binding to the cluster admin roles, and ensure the required labels are present. So we have things like environment, cost center, support group, application that are registered to CMDB. So we needed to make sure that they're already in place as part of the validation as well. So we use Gatekeeper to make sure that the governance is in place. Runtime security, containers are most vulnerable when they're running. Block unwanted syscalls. And these are tools like CrowdStrike, Falcon Sensor, and System Filter that allows us to detect threats and anomalies on the host and container levels as well. So with all of these things, the idea was to decouple the infrastructure-related implementations from application and provide them as a service. So getting a little bit of detail into EKS. So for cluster management, this diagram shows overall view of how everything integrates together. I think I mentioned before that the category is kind of outdated, but we'll continue on. So we use distributed cluster per tenancy per team. So every time we onboard the team, we deploy the cluster on their account, and also the environment types, which are non-prod and prod. This is also under shared responsibility model. Our cloud team, we call them CPS, organizes a landing zone, including shared AMI. So Neff creates the cluster, node groups, Lambda functions for sending control plane logs by the processor and any other Kubernetes internals. These are available for tenants to configure as well. So we've actually abstracted away the code that does the deployment, but the configuration is available for the tenants to use. And we provide spot node groups as well on top of default ones to allow for cost-effective solution hosting fault-tolerant workloads, such as ML training workloads. But more about the hub and spot model. So with the cluster topology, so CPS manages account provisioning updates for EKS landing zone readiness, and they create IAM share heap, which is the actual centralized AMI from their account. They set up also the secondary side range from the existing VPC, which they run ECS on for the application teams. Also create route 53 hosting zones and etc. So the IAM roles are prefixed as well. So this is an important part for shared responsibility and segregation of permissions, where we use the AWS organization to separate out using SCP policy to deny any tenant access on already existing landing zone. So if you think about it, you've got ECS running at the moment. Now we're making EKS available, and we're trying to achieve a hub and spot model by actually deploying our roles and clusters into it. How do you make sure that it doesn't conflict with existing resources already there? So any other unrelated resource management in the same cloud, we don't want to avoid doing that kind of stuff. So again, this separation is across non-prod and prod, and the Neff EKS team also has their own playground. So hidden away from here with the playground, which isn't exposed to any other team for development purposes prior to releasing features by patching. So it's all good in terms of having this hub and spot model, but our cloud team also has a concern because they want to make sure that we're not doing any wrong things from our side as well. So they're watching us, we're watching them, we're watching as a team, so it's kind of stuff. So it's kind of interesting. So how do we actually achieve this? So we also utilize a thing called boundary policies. So that's actually created by the cloud team. And these are mandated by the spoke role creation condition. So when the spoke roles are created cross account to the application team, so the diagram is a bit small, we use the conditions to make sure that the boundary policies are attached to any roles that we create. So those are mandated by the SCP policies by the cloud team, and then we must attach them. Otherwise, we can't create any IAM roles. That means those boundary policies with the statements and actions and resources and all that stuff is already pre-approved by the security team overall. And no matter how many things we create or how many actions we create, we cannot exceed that. slide here. So EKS Terraform structure. So initially, when we actually created it, we try to avoid the complexities of sharing permissions of KMS key and S3 bucket across account. So we'll create the S3 bucket on our account and then actually store different tenant state files. But we wouldn't actually store like one big state file. We would actually separate it out into kind of logical states where we could pick and choose depending on which updates needs to be done on the particular state. So if you think about it, this isn't everything, but on a high level, we kind of have like a cluster separated, then the auth that's related to AWS auth with IAM role creations, node group, because we do regular patching, so that gets used quite a lot more frequently than others. Then we have like a application state with all these controllers and gatekeepers and so on. And then we have a tenant state file as well for namespace and quarters and all that sort of stuff in there. So EKS sort of namespace structures, service account and vault. So we tried many approaches starting from one namespace per application and environment with the service account across vault. It caused a few problems around cost as they increase per Kubernetes service account. So that's when HashiCorp changes their costing model. And technical limitations were there as well. Things like Vault cluster only supports up to 3,500 Vault namespaces per cluster. And we needed to ensure that it doesn't go over this limit. Getting into AKS, so as a central cluster, we have depth test and prod environments across app and tooling clusters. And we use Velero to back up to Kubernetes resources and at schedule. And for disaster recovery, it's a regional based recovery because back in the olden days, Azure actually didn't have availability zone when we actually started. So we used the Melbourne region as a failover region to do this, which means that AKS cluster, Vault, key Vault, VNets, controllers, things like Nginx Ingress, kubectl, Opera, and jump hosts, all of these are pre-provisioned except for the application part. And once they have failed over, some of the pods annotation needed updating, so they fall back into Melbourne cluster. And those pod annotation with prefixes in there, things like Vault auth prefix from Sydney to Melbourne had to be adjusted. And also the cluster itself is deployed with the NEF AKS team by the Karpenter Enterprise. For Helm, so Helm configuration file with governance. So you can see the diagram here, Artifactory to store the Helm chart, which is private to our network. So we use git shard to retrieve app manifest file, which is available to the applications, and deploy and reference Helm chart versions on CD pipeline. So that means you must actually put the git shard as part of the pipeline execution, get checked out with the actual manifest code, and then use that as a Helm version, desired Helm version to be retrieved from our centrally provided Helm chart repository. So as chart versions are given to application config for tenants to update, they can update when they are ready to that particular version with that particular small YAML file that we provide, so that it doesn't introduce any breakages. So we can think of things like we have Helm values file, and then we have CPU, memory, replica count, HPA, PDB, or RSA, those kind of things we would allow it to be configured on their side. But also we have things available that are variable between the applications, so to make sure that the application requirements are actually meet. So Graviton adoption. So really, this was there for our cost saving. So roughly it turned out to be about 20% cost savings and more. And some containers, so as part of this initiative, some containers work with vendor supplied 64 equivalent images, something to watch out for. So it's not like you go into like Docker Hub or try to find out multi-arc images and all that. Some of those images didn't have an equivalent support. So there's something to watch out for, so that otherwise you just have to build it from scratch and then try to use it. But that also increases maintenance overhead as well. So extra work was actually required to rebuild downstream dependencies with ARM64 flavor prior to rebuilding upstream images. Both taints and tolerations are built into our central Helm chart, hidden away from tenant's vision. We only expose flags between ARM and x86 to be specific into what we call NEF manifest config. So this means that tenants do not need to know anything about the Kubernetes manifest to achieve the ARM deployment. For our workloads, we create multi-arc images, which is different to tenant application workloads. And for our accounts, we keep both for testing the application containers and also the node architecture on our account. So this kind of gives a bit of an idea of like snippets that is hidden away from the tenant, but the configuration is exposed only to the application side. So for the tenant side, we didn't really go for multi-arc path because the destination is ARM and we didn't want to go back to x86. So it was really this kind of model was actually introduced to allow it to be in-flight smooth transition into the ARM nodes rather than all or nothing approach. And multi-arc wasn't also chosen because of the large maintenance overhead. If you had multi-arc, then you kind of have to make sure that the builds are maintained and up to date and so forth. So then we have harness delegates. So I mentioned we use the harness for the centralized CI/CD pipelines. So delegates are basically equivalent to Jenkins agent, if you're familiar with that. So they're on standby. So what we would do is we would build it as a multi-arc, but it could deploy to ARM nodes as soon as they become available for initial rollout. The CI builds need to happen on matching architecture, but we would use a thing called build farm, which is like ephemeral code as part of the pipeline. So it gets provisioned by the delegate as part of the execution. And then those pods on the right for building images. And this decoupling was flexible and convenient because you could choose wherever you wanted to run on based on the parameters that you set as part of the execution of the pipeline. On the CD pipeline, so left is obviously CI and then right is the CD. So CD pipeline for deployment, we needed to inspect the image underlying architecture. So rootlessly, without causing any exemptions on our OPA policies. So we use things like a tool called Scopio, if you heard of it. So Scopio inspect allowed us to do this. This then allowed to decide whether we apply tolerations on the node that has taints on ARM nodes. There's been many tooling images used for achieving successful CI build, and they were prioritized depending on the usage of ARM compatibility. Porting Advisor. So it's a tool provided by Amazon. It's a command line tool that analyzes application code and suggests update if required to run on ARM, Graviton ARM nodes without issues. So it helped to plan out changes on images prior to starting their work. So there will always be edge cases, but it was a really good oversight before you actually start to do their work on it. So it's important to note that it doesn't make any modifications and also does not send any data back to Amazon as well. So it's very private, local to your environment. It's the fun part. So the people are pretty much still on IPv4. The consequence of this is that you always run out of IPs, especially for unexpected increase in usage due to wrong forecast. And fortunately, we can achieve zero downtime to use secondary CIDR. So that is like to RFC 6958 from RFC 1918 on primary CIDR that we have from the PPC. And without having to create the entirely the new cluster and migrate workloads over. So think of it like we have a mission critical application running on production. What are we going to do about it if we run out of IP? So we use custom networking for that using ENI config set for each AZ, so matching AZ name, and to allow automatically label nodes with ENI config of the same AZ. So we would achieve that by actually setting the configuration options on point number 3 there, and on the AWS node to make sure that they're automatically labeled as the node actually come up to utilize the CNI config. It's also something that interesting thing we found out as part of this journey was that kubectl exec and logs will be offline for 5 hours, but application was all up and running fine. And also important thing to note is the pods branch ENI will use trunk ENI of the node, not requiring any firewall changes for as a source for route as it remains the same. And external dependencies are unaffected, like things like Vault Cluster that would integrate with the Kubernetes pod. It has been tested and verified with VPC flow nodes as well. And then with all of this stuff, we would actually make it available with the next patching cycle. Secrets management as a service, we use Vault Injector pattern. Vault Injector is a tool provided by HashiCorp. It allows us to decouple secrets management integration with Vault from application code. It goes through mutating admission controller, so where it modifies incoming Kubernetes manifest by adding init first, and then the sidecar container if pod annotation is enabled for it. These secrets are reading off from code config map with Vault agent being spun up, loading secrets from a thing called console template under the temp.ff file system. This is all without exposing any files on the host. And console template, literally, we've actually made it to loop through all keys within the specific path under app name and environment, which is the following this naming convention in the middle there, which is app name and environment key. That means that there's no code changes required to achieve regular operations of adding the secrets or updating secret keys and values and so forth. And these files are then sourced and allowed secret values to be propagated into environment variables for application consumption. Getting a bit more into secrets management as a service, mentioned about the Kubernetes auth method to support the multi-cloud single Vault namespace. As you can see here, down at the bottom is the Vault cluster on the left and right. And it gets replicated from Amazon into Azure using a thing called performance replica. So performance replica is literally the term for Vault cluster where it actually replicates all the configuration except the leases, but the secrets are involved there as well, the replication. So things to watch out for is they watch out for firewall access and that utilizes the performance replica that syncs the secrets between the cloud and utilize short-lived token. So JWT token cannot be used easily if stolen from the cluster. So with the Kubernetes auth method, it's configured to use the path on the Vault to ensure including at least cloud and environment in naming convention so that we avoid a conflict. Because it's replicated, we needed to make sure that the naming convention is differentiated between the clouds. And also C8 cert is valid for the lifecycle of the cluster. So because it's used to configure the auth methods, this is also the case for Kubernetes host and JWT token for configuring Kubernetes auth method on the Vault itself. It is expected that cluster creation will automatically configure the auth method with this new data. Logging operator pattern is a Fluentd operator, runs as a daemon, set across all nodes, collecting logs at the host level, with the reloader aggregating config map instructions across all namespaces. Any logs related to Kubernetes administrators such as Docker system, service system, journal CTL logs, kube system, and other Kubernetes components like kube API server are sent over to Kubernetes admin Splunk. So the ones at the top here is administrators, which is the NAF team, and then the application teams are at the bottom there. We also provide things like the parsers, like multi-line parser for Java struct traces as by default. They're also self-serviced as well as a tenant config. So tenants are freely to open a pull request out of it if there's any changes to that. And then they can't deploy it, but they can make changes to the code base. Once it gets merged in, on the next deployment, we would actually do some regression and then do the deployment as well. Getting back to motivation. With the strategic vision coming from Andrew, everything we built were based on templates and reusable components that we've pre-integrated into CI/CD pipelines to Kubernetes platforms. All right, so centralized CI/CD as a service benefits outweigh the challenges. So reliance on a single platform introduces single point of control. Your services may be limited to SaaS providers' SLA. Central team must respond or resolve requests within reasonable internal SLA without impacting app teams' productivity. So they're also responsible for reporting and enforcing governance in collaboration with domain architecture, compliance, and security. So it's a balancing act. Permissions and visibility of knowledge and technology should enable teams to innovate. Balancing between security and operational efficiency is key to innovation. You can have all the controls in place, abstracted away from developers, but when incidents occur, provide access to gain enough information for engineers to resolve them and minimize mean time to recovery. Canary migration. So earlier we mentioned that we are migrating from ECS to Kubernetes. So Canary deployment, if you're not familiar with it, it's basically a safe way to deploy applications to production, minimizing impact with gradual rollout to small percentage of users in production. So it's different to RON deployment. So I often get a lot of questions about what's the difference between blue, green, and Canary. The answer is basically that it's all or nothing for blue, green. So it's 0 to 100% as you switch over. Whereas with Canary, you can impact small percent of users isolated at the level of pod. That comes with any other things like syscalls and Linux capabilities that might be called by the application with CPU and memory that may cause pod-wide fault. So these are intended for producers and services backed by API, for example. So Kafka consumers services are limited to how many connections downstream Kafka topic allows. So meaning during transition, we needed to be extra careful not to go over this limit. And as we likely double the usual active connections while we have active ECS and Kubernetes services at the same time. So at some point, that may cause errors. So the step one, so we use Canary with Kong API gateway plugin. First, we have primary run with 100% with a dedicated repository entry created for Canary and TBT as well on the entry. Then step two, divert the traffic to Canary endpoint, which we have as service B on EKS. For this example, we shift 5% of the user traffic from ECS primary to Kubernetes Canary. Canary deployment under Helm deploys with suffix that can be uniquely identified. So you would want to make sure that the Canary deployment is different to the regular logs and other sort of node identifiers that you would have registered to things like AppDynamics and Splunk. So that you would look for kind of like a health score of that or in a consolidated manner. And then you would look at anomalous errors just for that particular Canary. But also it's important to note that the logs, we found out that just because you have logs in production, it doesn't mean that it's actually wrong. Sometimes you have good or bad or false positives as well. So we've had cases, some application teams saying, hey, this error is actually normal because it happens every Friday because of the third-party calls that's been happening. So you got to be able to determine what's good or bad. When we decide if we are satisfied with this Canary release, we can promote Canary to primary by sending 100% traffic to it. Again, you can gradually roll up. Here's kind of a formula borrowed from Google. And Canary pod count increases to handle increase in traffic, matching current primary replica count prior to this. And then TVT is executed on Canary. Once fully switched over, we change Kong back in with Canary deployment with service B to primary, removing pod for now the old primary as pods. Sometimes we need to cover extended Canary. So it's an interesting part where you have applications that you might need to monitor for a longer period of time than the execution of the pipeline. Sometimes over the course of days outside of the deployment execution. This may be due to events of interest that might only arise at certain days or period where it needs to be verified with small subset of users before rolling it out to all users. So since we have a suffix for monitoring to filter out this Canary deploy, alerts set up for dedicated for this release can notify us for any issues if it happens throughout the journey. This one sort of gives us a bird's eye view of what target state we're working towards provided by architecture. Overall, the solution involves quick and painless deploys to production with all the security, reliability, cost, operational efficiency, and performance built into the pipeline. So app engineers have peace of mind knowing that pathway to production is following compliance and standards approved by various authorities within the bank. So realized benefits. The benefits we've actually achieved so far has been more than expected, with all metrics showing reduction in frictions, resulting in quick and painless path to production, reducing cost as well as increased innovation by enabling teams to always be compliant, secure, and up to date. This resulted in increase in all of the DORA metrics improvement, like from the baseline, and we've seen from all distributed patterns. Learning to share, getting pilot applications to teams onboarded and obtaining feedback early gave us valuable insights. So start small with a few, I would say, more skilled teams that may have missed as part of initial implementation. Involve pilot teams to improve and continue onboarding with the wider audience. It's easy to gold plate your solution and try to be perfect from day one. Define minimum viable product in detail, and interim solutions that lead to the target state solution. Involve security from start when you want to evaluate, so shift left on security or for tooling options. And by doing this, you avoid wasting time on wrong choices and involve vendor early to meet your delivery milestones. Okay, that's it. Thank you.
That's the awesome talk. Any questions? I know we are running a little bit late. Yeah, maybe just one question or maybe two. Or actually, just a reminder, you guys coming to learn, right? We will test you. Okay, don't go away. Towards the end, we are going to have the quiz time. And I don't have any other sponsor to provide me swag. So I travel around, I join KubeCon, I bring some swags back. Okay, so you guys do the quiz time. If you guys did a good job, the top, so we will give away some, swag that I bring here. So it's my own collection. Okay, so yeah, we will have, maybe have one question.
Hello, thank you for the talk. I see that you use Harness as a managed CI/CD. Harness, I'm familiar with Harness for a couple of years now. Your pipeline is very K8S centric. So I was wondering, are you exploring something like chaos engineering in your pipe? I mean, it's something that is off the shelf, I guess, at this moment.
Yes, we're using Greenman for that.
Chaos engineering, yeah.
Yes. Yes. So yeah, we've been exploring that as part of our NetTool offering, and we've got some of it integrated, but we're currently exploring that as well. But it's used across the bank outside of the team.
Thank you very much. Yeah.
All right.
So maybe just one more question.
Thanks for that. I was just curious on the shift left on security, because usually security is a bit slow and treated as a blocker. Is it also automated on your case, or is it like a conversation on how you design things? Just would like to expound more on when you said shift left in security. Thank you.
Oh yeah, so shift left of security is visually looking into things like it makes sure any vulnerabilities or if you want to introduce any tools, you want to make sure that that's actually discovered in advance as early as possible. So earlier on I mentioned about Snyk. There's also the tools out there that allows us to detect that at the not just at the CI/CD level, but on the IDE as well as the kind of scans across all the packages and try to find out mapping with the vulnerability database that they have. So it's really about focusing on those areas to fail early and also for the tooling choices, involve them early so that they get reviewed with all the information necessary from the start.
Thank you.
Thank you so much. Thanks, Jay. So let's welcome Frank to join us to give a talk about a Karpenter. So anyone hold of Karpenter? No, let's see. And yeah, while Frank is setting things up, so I'd like to remind if anyone want to join me as an AWS community builder. I don't work for AWS. Okay, I'm an AWS community builder. I love ECAS. I did a lot of the video sharing. I did a lot of the also talk about the ECAS, how to create the ECAS cluster, for example, how to back up a ECAS, how to do the migration. It could be, migrate between ACAS and the ECAS, for example. I'm sure you guys also have a lot of learning about the AWS. So join the AWS Community Builders Program. It's one of the big things. I enjoyed it for 2 years plus now, and it's coming to renew next month. So right now, the application is open up to, it's at 28. Yeah, someone reminded me that's 28. So if you don't know how to do it, yeah, feel free to drop me a message or talk to me after the session. Thanks, Frank. Over to you.
Thank you, Håkon. Thank you. Very glad to be here. My name is Frank Fan. I'm a container solution SA based in Melbourne. So my role day to day, talk to customers, talk to our service team, and help our customers to better use the service. But another side, I'm also part of the Kubernetes community. So today, very glad to share what I learned, and then hopefully you can get something from here. Probably start with why we have this topic, right? All right, cool. First, we talk about the challenge. What the challenge today we have about Kubernetes scaling, and we talk about Karpenter. It's about overview, but most importantly, probably I want to know the audience here. How many of you are familiar with Kubernetes? Hands up. Because it depends on how deep we can go into, right? Nice, awesome. A few hands. Thank you. And then we can dive deep into that. And in the end, depends. If you're interested, we will say. So do a demo or not, up to you. All right. First of all, why scaling is important? If it's a small environment like this, don't bother. But today you have lots of workloads, and it's not a trivial task. Can anyone here tell me why scaling is important? It's a small group. Feel free. Yeah. Absolutely. Your application team need your service up running. I need it now, or even better, yesterday. Right? Do you have capacity in demand? More? Why scaling? Absolutely. If you have application running business critical, when you scale out, you ensure it serves the request. But when you scale in, all right, I'm scared. Is that yeah, exactly. high availability when you scale in, and also I don't want to get the application already completed, but the node still continue running. I still pay the bill. It's not good sign, right? Yeah, more and more you need to consider, and also for the upgrade today, lots of security patches, lots of things you need to keep update. While you updating node, do you think your application will continue up running? Are you confident to put your hand on your heart? I'm confident I wouldn't get a call Friday night, right? It happened to me in the past when I was managing an environment. So these are all the challenges today. How are we going to resolve that? Yeah, Kubernetes community, we have solution. Anyone here familiar with cluster autoscaler? Hands up. Yeah, we have a solution, right? That solution is already there. How it works? You can say you have pod. When I say pod, it's workload running, right? But workload need to be run on the node, which is underlying compute, right? How that compute will make that available, a leverage here is called CA, cluster autoscaler, and then autoscaling group, which is a concept which a group can scale out, scale in based on demand, and then talk to EC2 API. I need a resource. I need a EC2 instance to serve my need. That's typical process, right? Simple. Anything wrong with that? Nothing wrong? Wait a second. All right, so this is what happened. You can see here, I have two node group. Each node group have different instance type. This one have smaller instance node. This one have slightly bigger double size. All good, right? Here, they're all running, right? Pretty full. But now I have workload upcoming. They are pending. I need a resource. I need to run. What happened? Our scaling group will scale out to get no new nodes. And then, here we go, happy. I find a home. Any problem here? Why? Actually, you're right. It's a tricky question. The potential there's waste. For example, if I only have this node group here, right, it's big node. If I don't have a smaller one, right? Even I have a small cubic here, I need to provision a big node. I need to predefine the node size. But who knows what type of workload will come in? I maybe provide a huge node to serve a tiny workload. It's not best, right? So this is a auto scaling, but beyond that, also operational overhead. Probably I noticed, Jay, you show your slides. I noticed you use Spot, right? How many node groups do you have today? A lot. Right? It's not a trivial task to manage a lot node groups, right? You need to remember, this node group for Spot, this node group for this instance type. Not easy to remember. And how do you can expect your application team know that, right? There are lots of the hand holding to ensure your right application running on the right node, not a trivial task to manage. Now we have answer. It's how Karpenter. By the way, today I'm working for AWS, but Karpenter is open source software. We talk about Karpenter, it's not just about AWS, it's software we already donated to CNCF, and it can be run on on-prem, can be run on other cloud provider as well. So today's knowledge, even you don't use it, that's fine. You just understand what's the challenges today, and perhaps you can think about how I can optimize my environment, right? How it works, this typical way, right? But we don't like the middleman. Let's get rid of them. Use one single approach, unified approach, and simplify this provisioning. And in benefits, can you think of? Sorry, I didn't talk about the detail. I asked you for benefit, but just give a guess. No? All right. Let's get into the benefits. First of all, cost optimization. I just provide the right size of instance for you and better utilize your node resource. And I can scale up and scale in based on your demand I don't leave the node continue up running. I will consolidate the compute. Secondly, diversity. I can easily provision different type of instance types and for your variety of the workload, like ML and Gen AI, which is sometimes unpredictable about demand. Last but not least, how many of you today manage Kubernetes clusters? Hands up. I'm sure you enjoy work, but is that walking in the park? Upgrade, patching all the time, you need to keep up to date. And it's not lots of heavy lifting, I would say. Let's talk about some details, right? When I talk about scaling, we need to understand what requirement customer asks for. Your application team, I want to scale based on CPU, memory, storage, network, CPU, on and on. And you, operation team, find the right instance type, right? It's like magic. How you going to find the right instance type? There are so many, hundreds of instance types. And we are not stopping here. We continue on with high availability. I want to provision a different availability zone. I want to make sure you always have capacity. I want to get the lowest price. So many dimensions you need to consider, put that into consideration when you determine instance type. And on demand and spot. Spot instance is a cost-effective way for you to leverage some additional capacity. But some caveat for spot is it could be not available for you, but give you notice for 2 minutes for you to properly shut down or properly evacuate your workload. So we'll have different strategy, right? For on-demand, always go with the lowest price. But spot, we want to have a balanced policy. We want to give you low price, but also ensure have good capacity for there to reduce likelihood of interruption. All right, let's get into some details, right? So here is a configuration will provide flexibility to choose the right compute. So here you can see the different I've already put in. This is 3 different instance type. You choose node from this family, right? Don't give my very expensive or big different instance type. And this is the size of instance. And then you can continue on to define, I want to spread across availability zones. And Jay mentioned about the graviton, right? I want graviton, save my cost. So use this different architecture here. And I want to save money. I want to spot. And I prefer spot before you give me on demand. So give you flexibility to define what you like. And anyone familiar with this concept here? Do I need to spend time here? Hands up if you're familiar with this concept about this. Probably just briefly, I wouldn't go to details, right? When you have nodes and you have your workloads, right? How are you going to ensure your right workloads always being placed in the right nodes? It's called scheduling. It's like just move this one, put in the right place, right? So these all the mechanisms already in the Kubernetes. I wouldn't go to details, but for you, information is a Karpenter integrated with them, all of them very well. So nothing new you need to learn from the scheduling perspective from Kubernetes side, but we provide more flexibility. I think there's a lot of details, but probably I will skip, given lots of the details here, but I quickly just mention here, you can say spot, you can always provision nodes. Sorry, make sure your port will be provisioned into right spot, right nodes. In this case, is spot. Lots of technical details, I'm not quite sure. Okay, this one probably is relevant. I have different teams. I have team A, I have team B. I always want to make sure this team A have that workload running a specific group of nodes, right? You can do that. You can set up your node pool, which is configuration of Karpenter, and you can set up your workload specification. you can see they're matching up, right? And then this particular node deployment will be deployed onto the right node, which has this label, right? This is something basic for how scheduling works. Optimization. So this is the fun part, right? We want to spend less, but we want to achieve more. And everyone need to have that cost in mind. So here we have policy configured. When underutilized, I want to consolidate. How exactly that works. Okay. Before we go there, you can say 4 nodes, another 2 nodes, pretty empty, right? Lots of empty, underutilized. Why don't we consolidate, get rid of them, and combine them in the existing 2 nodes? Right? It's easy to understand. In this case, this 2 node is quite large and have lots of space. Why don't we consolidate? Right? Change the instance type. Make a small instance is enough. Why need a big instance? So that's about scheduling, provisioning, but most importantly, Karpenter combines lots of functionality I mentioned here and make you operational work a lot easier. Easier for your upgrade, easier for your day-to-day patching, and we wouldn't go to details, but this onboarding, how you can do it, you can install that as Helm chart, but Karpenter, you need to find a place to run it because itself cannot provision or schedule workload for itself. You need to find a place. It's catch-22. So you still need auto scaling group or the node group to run Karpenter. You can also use EKS Fargate, which is a serverless option to run your Karpenter. And we provided comprehensive guide for you to do migration. I'm not quite sure. Should I do that? Should I do that? Should I do just talk through, or you want to see the live demo? I'm not quite sure. People, hands up. I will listen to you. Maybe I just play a video. This should work, right? No. Let's do the live demo, right? Hopefully it works, but if it breaks, it's live demo, right? All right. This should work. Okay, awesome. Okay, probably I close off this. Microphone, anyone, you can stop me anytime. You can break something. Yeah, let's do that. I can do troubleshooting, I can explain. Yeah, feel free to interrupt me, right? So this is not a presentation, or this is a community. Come on. All right, let's start with where we start. Do you want to see the code? Maybe start with the code. All right. We talk about a Karpenter, right? I need to define node pool here. You can see I define on demand, right? I don't want spot for the time being. I want this instance family from C family, M and R, right? Compute intensive. I set a policy when underutilized, please consolidate it, save me money. That's node pool, simple. When you apply this node pool, right? You will run the workload. This is workload. It's quite simple. It's just a placeholder here. It doesn't do much. It's pretty much a very simple deployment. Here you can see I only want to run my workload on the Karpenter. Don't give me any other nodes. I need Karpenter to run that for me. So you can see this type label here. That's pretty much, all right? Simple, right? So let's go to console. So I have already set up, first of all, we need to understand where is Karpenter. Karpenter is basically a deployment in come on, it's running, right? Simple, it's just deployment here. What it does is running on your data plane. Data plane is the brain to decide, do I need nodes? I need to pick up some nodes. I need to schedule tasks on this node. That's what it does. But let's look at our workload here. I just mentioned that deployment, right? Get ports. It's not running yet. Yeah, because I want to show you some magic. Before we run that, I need to let you know what's happening. Oh, by the way, in the back, can you see the screen? Is it big enough for you? I want to show you the nodes currently running. All right. Two nodes, but keep in mind, these two nodes are already there because when you're up running Kubernetes cluster, lots of kube system nodes, lots of daemon side, including Karpenter itself, need to find a place to run, right? This is your foundation. But the workload won't be running here. I will show you. So let's start my workload. Previously, it's 0. I have a deployment here. It's 0. But I want to, let's take baby steps. How about 1? All right. This is 1. Let's see what happened here. Not yet, but wait for a second. And then I will check. Ah, here we go. See? It's quite quick, right? So basically Karpenter immediately, oh, there's a workload need a home. Let me provision new node. You can see here, this type is Karpenter. It's on demand. It's ready. Okay, let's say, is it ready? Sorry. Is it ready? Here we go. We have 1 pod running. Bingo. It does work, right? But it's not what we want to see yet. It's cool. You can know. But what if I scale more? Now, in underlying bottom window, I scale. I make it bigger. To 12. Maybe I make it a little bit more. 20. Let's see what happens. All right. I think. Let's see hopefully it's right. All right, see, you can 2. We have more, but you keep 1 eye on here, right? Previously, you can see you get a C5 large. See? Now we have more nodes coming. You have R5, you have M5, they are not ready yet. But you can see, give some time. So what happened in backend is it doesn't need any auto scaling group. It pretty much Karpenter directly understand what you need and then talk to API and then say, it's very quick, right? Successful because these 3 nodes already ready. So they all provisioned by Karpenter. But what if, and it always happens, right? Workload changed. And let's go back. Instead of 20, let's go back to 5. And let's say the status. And actually, there are lots of basically command line tooling and also available for you to see. One of them is gone, right? Previously, we have 3. Now we only have 2 because we don't need that one. Right? It got rid of. So you can say it's very flexible, very immediately meet your need by changing, by finding the right instance type. But I want to help Jay, because you mentioned you have many node group to manage, right? You have Spot. We need to help you, right? This is NAV building. All right, how can we help with pick up the right instance type? Because this one on demand, I want to go with cost-effective instance type, which is Spot. It's easy for you to configure here. What I will do is I will firstly get the node pool. And then there's one node pool defined. I will do the describe. As you can see, this node pool definition only demand. How about we add more? What I will do, I'll just change on the fly. And then I just add one line, just one more line. Where is demand? Here. Right, I just change to Spot. And see what's going to happen. Yeah, here we have 3, 5. Are you still with me? By the way, any questions so far? Did I lose anyone?
When you spun up the 20 replicas, it came up with a C5, an M5, and an R5?
Yep.
Is there any reason it didn't just come up with 4 C5s? Aside from the fact they're all there isn't an option, but is there a reason it decided to?
Yeah, there are this is the bin packing strategy, right? There are lots of things probably put into consideration. So the policy, allocation policy today for the on-demand instance is capacity, which means I always try to find the most instance type with most capacity. Probably because it's dynamic changing. At that time, I guess maybe that particular capacity is most available.
Okay, so it was optimizing behind the scenes and that was the best fit.
Yeah, it always basically you can think about take lots of things into consideration. Depends on your what you're asking for, right? For example, you can start with instance type you define in your node pool. I probably good example here, right? So you have the definition in your node pool here, and then a node pool you will define the instance type you want to choose from, or you can also choose this instance type very expensive. I don't want to choose that. And there are some particular limit here. I don't want to go beyond this particular resource as a pool. And that's the first step. Second step, it also will consider your basically scheduling mechanism, because in your deployment, you probably have lots of tanks, right? What particular node you don't deploy into. I will assess your workload. This workload doesn't want to run on R5. So I wouldn't provision R5 or provision something else. So lots of things we will put in place to calculate. Yeah. And also, of course, availability zones, price, yeah, many things, smart things happening under the hood. All right, we just changed the one thing, right? Let's see what happened here. Here we go. See, we have one more line. Spot. Let's see if it's going to work. What I will do, I will scale this from 5 to 12. As you can see, I only have one. It's already, because, yeah, it's in the backend. It finds spot instance. So that's basically what I can do now to scale in. Well, when we are talking, it's already changed. So, and then you can see it will scale in because I scale from 12 to 5. So yeah, that's pretty much I want to demonstrate today, but there are a lot more you can leverage. I wouldn't have time. For example, it makes a lot easier for you to do the upgrade of your nodes and make it a lot easier for you to build a very consistent or resilient application. And let's switch back here. Just do a quick recap. It's open source. You can use anywhere. It's compatible with current native Kubernetes scheduling mechanisms. and also very, very flexible. Save your money by consolidation and simplify your day-to-day operations like upgrade or patching. In the end, lots of resources. Yeah, just you can get your hands dirty running these workshops on your own environment or join any AWS event. Potentially, we can talk more about this. Open for questions.
Any questions? We should have like a 5 or 8 minutes for the questions before I'm going to test you guys.
Sure. So we saw that with the Karpenter, it helped us with the node auto scaling. But how efficient it is, like with the version upgrade or the node rotation. For example, a lot of operational issues come when we have to upgrade the Kubernetes node version. So how efficient this particular tool is with the the version upgrades.
Absolutely. So when you trigger the change, there are many scenarios, right? You have to the patching of nodes because secure patch. You mentioned another common scenario. Yeah, I have 3 release. I need to upgrade my control plane and I'll upgrade my data plane. Yes, absolutely. That's one typical scenario we'll trigger. But Karpenter, what we'll do is basically it's always you can definitely set up policy here. Karpenter, you can have a controlled way to upgrade. Another way you can have set up the TTL. Basically, TTL expired, you will upgrade. But in the controlled way, what you do, you basically when you change that basically the configuration file, it will, we call it drift. And when it drift, it's different from the desired state. For example, if you have a new army built, you put a new army in, and then the current setting will match the current setting with your desired state. If the node match, I will basically make a change, trigger the change. For Karpenter also provide some control approach. It's called, you can probably go to that here, Karpenter.sh, and then set up there's one section called about drift. It will help you to understand how to do the upgrade.
So just the the proceeding question with that, when you say that you have the TTL for the upgrades, what are the scenarios, let's say, if those TTL expires? Because we have seen that the existing pods or the existing EC2 instance when doing the node upgrades, they if let's say if the upgrade failed or expired, they get hanging somewhere in the between, and then you have to start again, and you get a lot of the application issues or the server issues at that time.
Yeah, I would say this is resiliency. Application resiliency is probably a big topic. There are lots of layers you can start with. Right? First of all, Jay already mentioned in his talk about have you set up your PDD, or pod disruption budget, right? Have you already resiliency in place to ensure it's not disrupted some workload? And also from the application side, you can set up application level redundancy, or you can set up some like canary or basically route traffic, right? You can set up a new environment first before you upgrade. There are many things. Karpenter the same, right? Karpenter is basically make it easier to your underlying infrastructure level, basically make it easier for you to upgrade. But the resiliency of application, you still need to consider lots of best practices you mentioned here. Either take a blue-green, canary, or even rolling upgrade. It's fine. Rolling upgrade, basically, if you set up properly, because when you do a rolling upgrade, you potentially Karpenter, you can scale out, right? Have more capacity, and then you have your workload running on the newest node, and then you gradually calm down or terminate old nodes. That's how it works.
Sure, thank
you. You mentioned Karpenter talking to the EC2 API in particular. Is Karpenter also available for AKS?
Absolutely.
Or self-hosted?
Yeah, absolutely. Karpenter was innovated a few years back. It's an AWS project, but now already part of the autoscaler SIG. And so basically it's open source. Anyone, and AKS also support that. And on-prem.
Follow up then, I checked the docs and there's no guides on self-hosted and or AKS.
Okay.
Are there any planned, or is that?
All right, I would suggest you can probably look at this one, Karpenter.sh, and look at the installation guide, because I believe this is universal. It doesn't matter which Kubernetes cluster. You can continue using that guide to do the installation. Yeah. Yeah.
Is it available for Azure managed OpenShift cluster?
I would say OpenShift have its own way too, but if put it this way, if it's Kubernetes upstream compatible, I would say why I was surprised if it's not working, but we can double confirm that for you.
Okay, thank you.
It's just a deployment, right? CRD. Yeah, if it's Kubernetes, it should work.
So in terms of cost optimization, can you quote like metrics, like how much savings have the clients seen?
I love your question. What I would suggest, there's a great YouTube video you can see. You can search for Karpenter consolidation on YouTube. There's a proper talk about how you quantify the saving. The demo will show you when you're changing its type, it will calculate the money saving by doing that. Sorry, I already go beyond time, but feel free to ask me questions offline. Thank you.
Thanks everyone. So feedback, yeah, we do welcome all the feedback, whatever it's good or not good. So that can help us to continuously to improve. Okay, are we ready for the exam? All right, not really exam. We're going to have some fun testing. So actually, let me start the quiz first. And then if you scan the QR code, you should be able to join. No, I haven't started yet. Sorry. Yeah, let me start first. Sorry. Yeah, the Conf Hub actually pretty good. If you used before, you will see the experience, how to register, how to check in, and also we can have the fun quiz time. Yeah, so one just join. Yeah, please use your full name. It will make me easier. Okay, we're going to give away. I need your full name, especially for the cold cloud access. Yeah, we got a 12 already here. So we got a 26. I think we should have more than 26. Give another maybe 2 minutes. Are we ready? Come on, guys. Why only 26? Oh, no. Actually, I didn't scroll down. Okay, we got 50. Let's get started. So the first question. Yeah, let's see. Should be a very easy question. Can you guys see? Let me make it bigger. So here is a rule. You need to react very fast and correct to get high points. Okay? So only a few seconds. So what is the best way to manage scheduling of ports to specific nodes? Come on, guys. Are you guys really joining us for learning? Okay. So who is the leader? Tama. Oh, very good. Next one. So what is a tool used to decouple vault secrets management in Kubernetes? That was the one Jay mentioned earlier. Should be easy, right? Is a vault SDK, vault injector, vault agent, or console template? Pretty good. We got almost a half. Get it correct. Now Guardian is the top. Next one. During CI/CD range expansion, using custom networking on EKS, kubectl exec and the logs will be offline for how long? I don't know if you guys saw it. I saw it's in the slide. Yeah, it's Jay's topic. So is that 2 hours, 5 hours, 10 minutes, or none? Nice. It was slowly improving. 57, 54 correct. Tama, back to the top. Yeah, we got like six questions to go. So what is the method used for restricting access between AWS services and the EKS port? Either security group for ports, either network policy, security group, or port security policy. It's not easy. Yeah, it's tough. Again, Tama is on the top. Nice. So next question. What is the recommended method to ensure ports are evenly spread between availability zones? Is it endpoint slices? Is it poor disruption budget? Or tech topology spread constraints? Or resources being packing? Why? If you purely rely on guess, it's not going to happen. You want to be able to be on the top. A nice one. We got a 55, 57 correct. So we are halfway. The second topic about the second top part of the question is about a Karpenter. So what is the benefit of using Karpenter? Yeah, I know, Frank mentioned a few times. Is that for custom optimization or helps upgrade and patching or support diverse workloads or all of the above? If you know the question, don't tell anyone surrounding you. Very good. We got an 84, correct. So a few more questions. So how does Karpenter provision nodes? Is that via EC2 auto-scaling groups or directly with EC2 fleets? Or could be Kubernetes cluster auto-scaler. The last option daemon sets. Well, again, if you guess, you can't get it correct. Pretty good, 51% correct. Yeah, because of Karpenter, actually, you don't rely on the Kubernetes autoscaler. So a few more questions. The next one is, what capabilities does Karpenter possesses? So provision nodes, scheduling nodes, consolidate pods, all of above. This one should be very easy, right? Yeah, very good. So last two questions. Which method can I use to scale nodes in my cluster? Is that vertical pod autoscaler? Is that horizontal pod autoscaler? Or Karpenter? Or K8SUG? Wow, this one, I think that's the easiest one. Yeah, it's very good. 86. I think the last choice. So Joshua, the top, Priya, the second. How does Karpenter dynamically select the instance types for spot instances? Is that lowest price? Is that price capacity optimized or capacity optimized? The last choice, most unlikely to be interrupted. Hard one. Yeah, the answer is the price capacity optimized. If you just go the lowest price, it doesn't fit the needs, right? Okay, that's all good. Let's see who are the winner. So according to the leaderboard, let's see. So Code Cloud are going to give us the Code Cloud access, free access. So that costs like even for the year, it's about like a $500-600 US. So we're not giving you 12 months, 6 months. That's also pretty good. 6 months you can learn a lot of stuff, but not everyone. So far I can manage the three, but one already reserved for our volunteer. Okay, so 2 giveaway. So the top 2, who is Zizong? Zizong is here? From online. So if anyone join online, it is also doable, but we need to get the confirmation, yeah. And the second one, per year. Yeah, do you mind come over? Let's take a photo. It's a big deal. I managed to actually, I met the co-founder, the founder from Code Cloud in Chicago last November. So I was talking to him, we can help you to promote your learning platform. Are you able to give us some, free access? So they gave us the free access. Yeah, I don't have anything to show Code Cloud, but let's take a photo. Thanks, Priya. Do let us know your full name, your email address. Did we find the Zizong? It's online. Okay. So yeah. So yeah, because it's a digital stuff, so we also give people join us online. So the first one, so the Code Cloud access, it's already gone. And the rest also, I bring here, my own collection of the swag, some of the tissues, if you like. And the first one, let me see. We're going to give away, because it's my own collection, so the size of maybe it doesn't fit for you, okay? Actually, this one is a XL size. This is from our K8SUG. Pretty unique. You don't find the same tissue from any other place. Okay, we got the XL. So who is going to take the XL? I ask from the list. Is a Michael? Michael, do you want an XL? Yeah. Okay. Come over. No, you're the first one. You got a choice. You can choose the size. I also have some other t-shirt if you want to, M size or.
No, I'll take it.
You take. Okay.
Yeah.
Let's have a photo. Yeah. Thanks. Oh, the next one, Malith. Let me see what I have. It looks M size is good. Yeah, let's see what I have. Oh, you are lucky. I think that's the one, anyone hold of tyke. That's the one I got from Kubernetes in Singapore. Thank you. Thanks. So what's next? Josh. I don't think I got the right size for you, but let me have a look. M size? Yeah, this one pretty good. DevOps is there. Thanks. Next one, FFY. Yeah, come over. Let me see. What else I have? I give it a very nice color, okay?
Oh, that would be great.
So the only yellow one.
Okay.
Yeah, this is actually pretty good.
What is that? Oh, this one.
Anyone heard of the log Z? Log Z. That's also one of these I got from Kubicon. Thank you. Daniel. So the next one, Daniel. It's all right, feel free. Yeah? Okay, next. Who is Evan? Yeah, come over. Let me see. Come on, what's the size? What can you see? My eye. Have a look. If M. So good size?
Yeah.
This is also one of these I got from a Kubicon. Yeah, take it. Yeah, come here. You know why I take the photo? I need you guys to help me to do the social promotion as well. Yeah, next time I can ask more sponsors to send us the swags. Okay, good idea. What's the next one? I think is a male. Yeah, let me see what I have. A socks. Yeah, also pretty good. It's from one of the security company. It's called Armo. I don't know if you guys are hold of Armo. It's also, they also have the open source called Kubescape. I still have some stuff. I'm not going to, read one by one. Do you guys mind to come over, take a group photo? So I should have the rest, like the pen also pretty good. So I should have enough for everyone. Okay, let's take a group photo. Yeah, please. Yeah, I want you guys to join us to celebrate the 1,000 Kubernetes user group we call K8SUGers. Okay. Yeah, come over, take a group photo, please. 这个
Put
等
on
会
a
儿
table
就
later.
看到 Yeah.
Yeah, with the stickers. Yeah.
And also I have the Kubernetes stickers. So you guys saw some sticker over there. I do have some special keep here. So after the photo, I will leave it on the table.
Yeah. The lights on the page.
Okay. We are going to have to switch now. I get like memorize it in the chat.
Yeah. 1, 2, 3. 1, 2, 3. 2, 2, 1, 1, 1.